Hello everyone, we are Team PSG. Um, my team member is Li Yufan. I am Wang Shenhao, and we are start the presentation. And first of all, we will start with our circuit structures. The first component is the counter, which is made with a decoder and 8-bit counter to calculate the count. A sorting machine, we, which will produce leaf and later put in a similar structure two components, one a shifter and a coder. After the process, the mask and Huffman code will be outputted. And next, we talk about the sorting algorithm. There are two choices. For one, we mix algorithm with one sorting and six heaping, which will add up to 36 comparators. And the other is all heap method, which will ultimately add up to also 43 comparators. Although they have a similar in number of comparators, they have their advantage. Heaping methods is pretty straightforward, but since it needs to customize every component, it is quite hard to do the pipeline. And that's why I choose the mix method. Though sorting takes a lot of time with the time complexity of big O of n log n, but thanks to two-list method, only the first time it is required, the reset is big O of 1, while heaping is always with a time complexity with big O of n log n. So we first discuss the sorting method. We use the circuit, the binitonic sort. The sorting algorithm is made with 6 steps, though the advantage isn't quite stand out in the 8-element circuit, but it is an modularized when it the spot for the sorting algorithm. Next, we explain why the two-list method work. So, we work with two lists. The empty slots will be filled with 128 to ensure they won't interfere the circuit. As I cycle in the PPT, we only need to comparing the first two components of each array, since every time adding make the next number bigger than last sum. It's pretty safe. We consider array B also a sorted list, and that's why you only need to use 4 inputs and total of 2 comparators each step. We also demonstrated the special occasion where if all frequencies are similar, the two-list method will still work under extreme conditions. Next, we use leaf to construct the mask and Huffman code. Since these two outputs only use easy 2-to-1 mux and shifter, it is quite fast to put them as combinational circuit. As shown in the PPT, the leaf will be an array with 8 bits, so it won't be that big to store. It works as each step of heaping and sorting the leaf will do the bitwise OR to always keep track of what components are stored in the current leaf, which will come in handy determine the Huffman code and mask, though we do need to be a little more careful with Huffman code. The mask building is quite easy, since we know the more time one symbol is mentioned, the longer the mask will be to the mask builder will just be 2-to-1 mask with 7 lines together. And for Huffman code, we have a similar idea but with tiny difference. With one the Huffman code builder will have 3 state 1, input 1, input 0, or don't do anything. which made it a 4-to-1 mux, and the Huffman code is built from the root to the leaf. It is worth to notice the input should be sent in a reverse order to we get leaves. A problem we can improve the circuit. How should we balance the pipeline to improve delay and strike a balance in area surface? Next, is there a better way to process the mask and Huffman code outputs? I think we do try our best to figure out circuit algorithm, but we still question whether there's a better way to process those outputs. That's the better way to write a very long array, which is pretty hard to do, but we are still reading articles to better improve our linking code. Next job assignment, we will be doing the circuit design and algorithm composing, and I will be doing the coding style check. Next is Gantt diagram. We will be testing the circuit this week, and we are looking forward to finish the circuit in 2 weeks. And about the problems we may face first is, as we started before, how to strike a balance between the working speed and area of the circuit. Maybe with changing the code with other algorithm will work. Algorithm ultimately fail. We were composing lots of way to build the circuit, so it really isn't a problem. Yes. Bad team cooperation will be solved with good trip to the $5 Kangi. And that's for the presentation. Thanks for listening.